All right, so we're going to graph number 2, and I think we'll do a quick graph of 3 and then come back and talk about all the domain and range stuff. So what I want us to do is to not make so many tables and kind of speed things up. So what I need for you to understand is that these points could actually go straight into this table if I think about it. So first, what I will be using to make the parent function is what's boxed in here. And that if I look at it, that I can see what I actually want to use to make the table. So I'll be using 2 to the x, so this little part right here. And normally I would make 2 tables, and the x of the first table would become the y of the second table. So I'm just going to go straight to that and make the x's that would have been a table the y's of my new table, like this. Okay? And now what I'm going to do is technically put these, even though they're y's, put them into here to get the x's. So anything to a 0 power is 1, 1 to the second is 2, 4, and then I get the half in the fourth. So notice between problem 1 and problem 2 that I end up with the same points. So again, just to reiterate, I don't want to make this table because I'm going to make this table and just switch them into this table. So I'm just going straight for the final table. Okay? So I'm going to take these points, and if I look at what I've done so far is sometimes I need to make another y, and this is a problem where I need to make another y because these y's have a stretch applied to them. So I'm going to take all the old y's and apply the stretch that we said was the 2. So all these numbers are going to double. And I don't need the old y's anymore, so you can kind of ignore those. And I'm just going to graph the new y's. And again, like before, I'm not going to graph the ones with the fractions. This is growth, so I should be looking for this shape. So what you can't see right now, well, I'll go ahead and put it here. I'm at 1, 0. Instead of putting 1, 0, 2, 2, and 4, 4 on there, I want to go to 1, 0, not actually mark the point like I have right now, but to take that point and move it left 2 and down 1. So what I'm going to do is erase 1, 1. Imagine that I have my pencil resting there, and I'm just going to take that point and go left 2, down 1, and that will actually be the final point, if I can get it to show up. Right, let's see. Make sure I didn't. Okay, left 2, down 1. And then I'm going to go to where 2, 2 is, and then take that point and go left 2, down 1. So it actually ends up here. And then 4, 4 will also go left 2, down 1. So the other thing that has moved is my wall, which is technically on the y-axis. It has also moved too. So it's going to be here. And that is at x equals -2. And I'm going to make my lowercase r now. It's going to coast up along the wall, and it's a little bit more stretched out than the other one was. And again, we'll come back to domain, range, and all that stuff in a moment. Let's just practice one more quick graph. And again, I could make 2 tables. I could make a table for this, and then switch them around for my log parent function, but I'm going to just go with 1 table, but I'm going to use this to help me make this 1 table over here. So again, normally I would pick the x's for this table, but those x's that I would normally pick of -2, -1, 0 will just become the y's. And I'm going to take these numbers, and again, I'm still putting them into here. So anything to a 0 power is 1, a third to the first power is a third, and a third power to the second power is a third to the second power is a third times a third, which is a ninth. And when you have the negative exponents of those, they just flip. So I get 3 and 9. Again, sometimes I need to make a new y column. I don't here because I don't have a stretch or compress. I'm not going to graph the fraction ones. Before I graph them, I do want to think and realize that this is decay because this base in either situation is less than 1. So I should just be seeing the same shape. So I'm going to go to 9, -2, and then move that point right to up 1. So I'm resting my pencil at 9, -2, and I'm going to go right to up 1. And it's a little bit off the graph, but that's okay. And I'll go to 3, -1, and go right to up 1. And then finally 1, 0, and go right to up 1. Excuse me. All right, so the final thing that's also moving is my wall. My wall is going to go right to, be right here. And this time my wall is at x equals 2. And I'm going to have it coast along the wall and then start that going down shape. Okay? And so it is decay. I mean, it's going down in the end if you take a look at it. All right, so let's talk about these arrows, because normally in the past with the arrows, we have put infinity symbols. So let's start with this first arrow all the way over here, okay? So this arrow means it's pointing to the right, and when it's pointing to the right, that means the x's are getting bigger, so I put infinity. But as it goes to the right, it's also going down. So y's reflect my up and down. So for the y's, I'm going to put negative infinity. All right, had to take a little pause there. So we addressed the right arrow. Now we're going to address this other arrow over here and talk about what's happening. So notice we're, if the shape, and I look at this arrow, I'm going to the left. So normally when this left arrow, we would put x's going to negative infinity, but x isn't going left all the way. It actually gets stopped at this wall. So what I'll write instead is 2, because it's not going to negative infinity. It's getting stopped at 2, but it is going up. And so for y, since it's going up, I'll put infinity. So just something to keep in mind, but let's use that stuff to finish up our graphs here. So let's start with number 2. With this arrow on the right, it is going to the right, and it's going to keep going to the right. So x will be getting bigger and bigger and bigger. But as it's going to the right, it's also going up, and that means my y, since it's going up, will get bigger and bigger and bigger. So that arrow represents infinity, infinity. When I do this arrow, which is going to the left, it's going to the left and down. It is going to the left, but it's getting stopped at -2. But since it's going down, I'll have negative infinity. And now I can do my domain, and these things are what I'm going to be using. So the domain is my x, my smallest x to my biggest x, and that was a -2 to an infinity. Infinity is always parentheses. So the -2 is also going to be in parentheses, because a bracket means it gets to be at -2 or touch -2 or reach -2, and it's never going to touch the wall or cross it. So it's going to get close to -2. So since it's not going to ever be -2, I put parentheses. My range are my y's. You have two options. That's a negative infinity to infinity, or you could just write all real numbers. The shape is increasing as we go left to right, and again I use the x values to describe that, so -2 to infinity. We left out positive and negative, and then we had end behavior. So end behavior was this horrible thing to write. And the first one, x is going to infinity. That I showed right here. And when x is going to infinity, the y's are also going to infinity. So for f of x, which is y, I'll put infinity. And then we would do the other one, where x is going to a negative infinity. Well, as it turns out, x never went to negative infinity. It got stopped at -2. So what we're going to write for the f of x is, you could do this, you could write does not exist, you could write non-applicable, but you do not leave it blank. All right, the other one, let's do our arrows. So on the right, this is going to the right and up, nothing stopping it. So to the right is infinity and up is infinity. And now this arrow, which is going left and down, it's going left, but it's being stopped at -3. And since it's going down, that's negative infinity. So my domain will be a smallest x of -3 and a biggest x infinity, parentheses, again, for the same reason. It won't touch -3, this shape, it'll get close to it. Range are my y's. I will just write all real numbers. This shape is increasing as I go left to right, and I use the x's. We did leave out the positive and negative, and then we did the end behavior. So x is going to infinity. It's going to infinity right here. So for the y, whoops, which is f of x, I'll put infinity. And I'll do the other one where we write x is going to negative infinity. But again, it doesn't go to negative infinity. It gets stopped here at -3. So for f of x, we will write, I've been writing does not exist. I think this is what they're looking for in your future math classes. And that's your graphing. So we will be doing 3 and 4 and 5 in class the next time. But that's all that I will be making for the video.